Okay. A zero of a function f is a number for which f of x equals 0. So that's like, it's an x-intercept. It's where the function equals 0. I'm sorry. Oh yeah, I do have another page down here. Okay. Real zeros of a polynomial function. So if f is a polynomial function and a is a real number, the following statements are equivalent. Okay, so in other words, these four statements here that they give you are all the same. That's what it means when it says the following statements are equivalent. So these are all saying the same thing. X equals a is a zero of the function f. X equals a is a solution of the polynomial equation f of x equals 0. X minus a is a factor of the polynomial f of x. And the point a0 is an x-intercept of the graph of f. How do I find zeros? All right, this is what this whole section is getting to. How do I find where what we now want to know is where do these graphs cross the x-axis? Where are my intercepts? Okay. Well, you know what? Okay. F of x is what? If I want to find this, what am I going to do?
0. Yeah.
Because it's y. When is y 0?
49.
Okay. Now what? This is the part that sometimes seems to bog you down, the
7.
math part, right? Huh?
Back 49. But it's minus 49.
Now what?
It's minus 49.
I'm sorry. Yeah. Now what?
Take the square root of it.
Well, what do you want to do first?
Get rid of the
Divide
square root.
1.
Divide them both by -1. Just gets rid of the minus sign, right? Gets rid of the.
And that's
Plus
squared.
And what is it? Oh, so it's x equals plus or minus 7. So that tells me that 7, 0 is a 0 and -7, 0. It just tells me that in this particular function, that's going to cross the x-axis at 2 places. And we know that it can do it at most 2 places. And it's going to be at those 2 points. That's all we're looking for. Well, it gets more difficult. What about this one? Because this one's we got a 4th degree polynomial. So this one's sort of easy, you know.
Factor out x squared.
Well, what do we do first? So we're going to 0 this, right?
Yeah.
Okay, now how am I going to do it? You started to tell me. How am I going to do it then?
I don't think
What?
sounds right, so
Well, what are you saying?
no.
Just tell me what you're saying.
I want to do it on clear before.
What do you got to do, Kelly?
Subtract.
What do you see in every
Factor out
term?
an x squared.
Factor out an x
Oh,
squared.
I was right.
I know you were right. That's why I said don't be afraid to say what you said.
But I am afraid.
You're not. I'm not going to think you're dumb. Don't worry about it. It's all right. Just say
You
what you
should
think.
think I'm done because it's
So
true.
x. It's not true. God made you
And
wonderfully.
minus x.
Minus
Maybe
x minus
Oh, yeah,
20.
minus-
Ooh. I got
Okay. Well, now what?
Do
Just
the
grab our x squared.
X.
We're going to factor that, right?
Yeah.
What are we going to get?
X minus 5x plus 4.
X minus 5, x plus 4.
See,
Okay.
That was fun.
And so now we have x squared. For these to be 0, we're multiplying those, so any of those can be 0. So x squared equals 0, so x could equal 0. X minus 5 could equal 0, where x would equal 5. And x plus 4 could equal 0. X could equal -4. So my zeros are 0, 0, 5, 0, minus 4, 0. What's the most zeros I could have?
3.
It's a 4th degree polynomial, so I could have 4. It can cross the x-axis 4 times. It doesn't mean it has to, but it can cross 4 times. If you drew this out, you'd see that there was a loop up at the. If you drew this out, how's this going to start and finish? How's that equation? What's this graph going to look like at the start and finish?
The x squared.
It's going to rise to the left, and it's going to rise and fall to the left. Okay. It's going to rise to the right and the left. I'm sorry. Okay. So it's going to do this. And it's going to do this. It's going to flatten down there. You're going to see.
Oh,
And so
ew,
it tells
what is
you,
that? That's
my drawing's not good, but if this was going to be, you have to over there more to get the 0, 0. And then it would be
ew.
5, 0 over here, and then it would touch down right over there, and it'd be 4, negative 4, 0.
That looks really dumb.
They can look any way they want.
You can
That's all you're doing. You're looking for zeros.
Class can be whatever they want to be.
Repeated zeros. For a polynomial function, a factor x minus a to the k, where k is positive, so the exponent is positive. So any polynomial with a positive exponent, a positive degree, yields a repeated zero at x equals a of a multiplicity of k. If k is odd, the graph, so if this is an odd number up here, okay, if it's an odd number, then the graph crosses the x-axis at the point x equals a. Well, so let's pick a number, and because this is, you can fill in any number, Kelly. Just pick a number. X minus, pick a number.
6.
X minus 6. Then pick an exponent there, k.
3. No.
Yeah, 3 is okay. Any number. Okay. So if k is odd, which it is, the graph crosses the x-axis at 6. So we know that if, in other words, if your polynomial factors out to x minus 6 to the third, and if you wanted to, you could take x minus 6 times x minus 6 times x minus 6 and find out what the whole polynomial is. You could. But if you could factor it down to this, to a cubic or to the fourth, any particular exponent, then you already know one of the zeros here, and it's going to repeat. That means that it's going to do it multiple times. If k is even, the graph touches the x-axis. So notice if it's odd, it's crossing the x-axis. If it's even, the graph touches the x-axis, but does not cross. It makes it, that's where either relative minimum or relative maximum will be, okay? Depending on whether your coefficient is positive or negative, whether it's opening to the right or falling to the right and left, or rising to the right or left, depending on whether it's positive, will determine whether your vertex is a minimum or a maximum. You have a minimum or a maximum. So this all you're concerned with here is this exponent. And that tells you whether you're crossing your x-axis or whether you're landing on your x-axis. I did this one from a couple days ago, so I didn't remember how many pages I had. And then finally, this section closes up with the intermediate value theorem. So this is the idea. Now this can be, for some reason, this confuses a lot of people. And it's really not that confusing. So don't overthink it. Let a and b be real numbers. Pick some real numbers, Kelly. Give me 2 real numbers.
4 and 7.
Okay. Let a and b be, for some reason when they write these out in words, this is what confuses you and a lot of other students, because you can't, in your mind, imagine what a and b are. So when you see these in the book and you're reading through your book and you're filling out your sheets and you're sort of reading through to understand this, put some numbers in. Get out some blank paper and just throw some numbers in. So when you see this, just throw, and it may make more sense to you than sort of the abstract a and b and f of a and f of b. Actually put some numbers into it, okay? And you may understand it better. If f is a polynomial function such that f of a does not equal f of b, okay? They're not the same number. Then, in the interval between a and b, the function takes on every value between f of a and f of b. Well, before you get too nervous, what did we say about functions? They're all what? It starts with a C.
Constant.
Continuous. Okay? All right? That's saying that you're not going to get, I get weary sometimes drawing there, you don't really see it real well. That means that you're not going to, here's my A, here's my B. It can be any numbers except for the B is to the right. It's greater. Okay? What that means is you're not going to get a graph that looks like this. It means that it's continuous, so that it takes on every value in between there. So if you have 2 numbers, then there's a value for every number in between there. That's all the intermediate value theorem is saying. The intermediate value theorem concerns the existence of real zeros. So here's the idea. If you know that one number is negative, gives you a negative value, and another number gives you a positive value, that tells you that there's a 0 in between. So let me see. Okay, if you have a function, all right, and this one we'll say is f of x equals x cubed. Oh, sorry, that's a horizontal shift, so we'll call it x minus 3 cubed. So that's what I drew there. I drew a function f of x equals x minus 3 cubed. That means if I have a value here, whatever a is, whatever that number is, it's going to yield me f of a negative number. And then I know that there's another number, call it b, anything in between there, that f of b is going to give me a positive number. I know my graph is continuous. That means between f of a and f of b is a 0, is where my graph is going to have a 0. It's going to cross the x-axis. And this whole section is finding zeros. It's finding where my function is crossing the x-axis where I have a 0, where f of x equals 0, okay? So all this long language tells you that if you know that, you can find a 0 because you know there's something in between there. And that's what you're going to see. There's exercises in the books where it'll show you you have a positive number. If you pick this, f of this number will be positive, f of this number will be negative, and so in between there must be a 0 to find. The idea is because, remember, not just because you can have a 0 doesn't mean that you have to have a 0. So we said before there were graphs. Let me give you one. X cubed plus 12. So this x, actually, that's an odd one, I'm sorry. How about this one? X squared plus 12. Well, you know what that one looks like. That's just a parabola that's been vertically shifted up 12. How many times is that going to cross the x-axis?
Never.
Never. But how many times could it, based on the fact that you have an odd, even degree? Twice. But it doesn't happen. So in other words, just because it can cross doesn't mean it will. So if they give you something in one of your exercises and they say, here's your function, x to the 5th plus x cubed minus 3. And they say, find the zeros, find how many times that crosses. Well, you know it could cross 5 times, but that doesn't mean you have to have 5 answers. Okay? So this intermediate value theorem helps you to determine, do I have zeros? Is there a place where it crosses? Is there ever a place where f of a will give me a negative and f of b will give me a positive number?
So you're basically looking.
You're looking to find that. Yes, that's exactly right. When you get down and you factor these things out, this is an actual problem in the book, so I don't know what the problem in the book was. But when you actually factor these down, it'll be easier numbers to work with. But it'll be very quickly whether you have a plus or a minus, whether you're going to have opposites. Yeah. So you'll know whether or not there's going to be a 0, or if, like yesterday's homework, there were a couple where we answered where there's no intercepts. Now we're just not calling them intercepts, we're now calling them zeros. All right, so I have an example down here. All right, so get out your graphing utilities. We've got like 3 minutes left, and just graph that.
Yeah.
And then use your graph. I picked the graphing window for you, so use that for your graphing window. Okay? I'll do it this way. Cubed, that's 32x squared plus 3x plus 5. Okay, then menu, window zoom, window setting zoom, and x from.
Can't you just do zoom and then fit?
I do have a function that I don't on my calculator. Maybe I do have a function that I don't know how to use.
Under zoom, window and zoom, there's one that says.
Oh wow, I got it.
Says zoom.
Looks like mine, right? Looks like that.
Yeah.
Oh, no.
You may have, there may be more than one function. That crosses in 3 places.
Yeah. No. On the
All
x.
3.
On the x-axis.
Oh.
On the x-axis.
Yes.
There's 3 zeros.
Oh, I multiplied it to that.
All right. You have the homework for tomorrow. It's on your sheets. Please have it done when you come in.
Alright.
Seems so sad.
What?
Seems so sad.
I don't know.
No, I'm fine. I'm fine.